Hello, my name is Emre Erçelik. Our group's name is Gravity. Today I will present you our ME 362 Project 1. The program is divided into three sections: Preprocess, Process, and Postprocess. I will start with Preprocess. At the left top side of the Preprocess, there exist two entry places that allow user to enter node coordinates. After creating at least two nodes, the user can create elements too. In addition to this, if the user makes a mistake, the program warns the user. Near the node and element entry place, there's file importing entries. The user can easily import certain structures if the necessary files exist. An example file is like this: enl and el. After writing the name of the files, the user can import structures. And with Assemble Files button, the user can assemble a structure. As you can see, the structure is built immediately. At the right side of the plot, structure information is placed. The user can learn number of nodes and number of elements. In our program, it's possible to edit the structure. The user can delete nodes and elements from the rightmost side of the preprocess. Remove all button cleans all the former information and creates a blank program. The user can also toggle on and off the node and element numbers. And most importantly, in case the user forgets the best professor in the world, there's a button that reminds the user the best professor in the world. In process section, the user can adjust the boundary conditions and material properties. After entering a node number, the user can set the boundary conditions. If the displacement is 0, the program updates the plot accordingly. For example, node 1 cannot move in any direction. The force conditions are shown in the plot too. The head of the arrow indicates the force direction for validation purposes. Magnitude of the force is also shown in the plot. The user can reset the boundary conditions with Clear Boundary Conditions button. After pressing this button, boundary conditions are removed from the plot. In Global Material Properties, the user can set the Young's modulus and cross-sectional area of all elements. The default Young's modulus is 10 to the 6 pascals, and the area is 0.01 meters squared. The Young's modulus can be entered manually, or the user can select the material from the list. If the user updates the material, the entry also gets updated. The Young's modulus information is stored in the third column of elements list. Here's an example. After setting the material as copper, the entries of third column are set as Young's modulus of copper. The user can also adjust the cross-sectional areas of all elements without converting it to meters squared. The program converts it automatically. The user just needs to select an unit. As you can see, after setting the area, fourth column of the elements list gets updated. In our program, it's possible to edit a single element's properties. For example, element 6 may be a steel specimen, whereas others are copper. In addition to this, element 6 may have a 0.02 meters squared cross-sectional area, whereas others have 0.01 meters squared. We can see the changed variables in elements list. Sixth element has different variables from others. After setting all nodes, elements, conditions, materials, and areas, the user can run the simulation with Run button. After pressing the Run button, the stress and displacement plots get updated. The user can increase the scale to see the displacements better. Note that the structure is not symmetric, because the sixth element is steel, whereas others are copper. The user can change the plotting colors. And also, the user can see the X and Y displacements separately.